Let's see how to idealize structures and loads. An exact analysis of a structure can never be carried out because the loads and strength of materials to be used are the estimated values only. Distribution of loads and their exact point of applications are also estimated. The main goal of the structural analysis is to establish the member forces and deformations as accurate as possible. Hence, the details of the structural system and their makeups are ignored. This helps to simplify the analysis. However, it is important to make sure that the analysis of the simplified structure still produces the result as that of the real structure. Let's see an example of simplification for analysis. Consider the bridge truss shown here. The initial step in the simplification is to consider the structure to be composed of two longitudinal trusses, 1, 2, that span across the river and they are connected by the transverse frame. The members are represented by lines and they are connected at their ends by pins. This is a joint and is represented by a circle. The two supports are pin and roller support. This is a roller support and is represented by this figure. This is the pin support and is represented by this figure. This is the complete simplified truss. In this simplification process, the straight curvature of the roadway or camber is ignored. Members are represented by straight line. Supports are taken as roller and pin. The joints are assumed to be pin. In general, for truss and frame structures, the length of members are significantly greater than lateral dimensions. Hence, the members are taken as linear members between the joints. For truss with pin joints, it is assumed that the joints are completely frictionless. The joints are assumed to have zero moment resisting capacity. Now let's see how to represent the loads. Loads can be classified as concentrated loads, line loads, and surface loads. Concentrated loads are applied on relatively small area. Loads of a column to be transmitted below can be represented by a point load. Similarly, loads from four legs of a chair to the floor can also be assumed to be concentrated loads. Because of small application area, they are assumed to be applied on a point. Next is the line loads. Line loads are distributed along a narrow strip of the structure. For example, the load of the beam itself is distributed throughout the beam, hence can be represented by a line force. The line force can be uniformly distributed or they can be of irregular distribution. Surface loads are loads that are distributed over an area. The load on a warehouse floor is an example for this one. Let's talk about idealization of supports. There are a number of supports that you may encounter in structures. However, three basic types of the supports are the roller, pin, and the fixed supports. A roller support allows some freedom for slight rotation of the member and also allows for the movement of member in longitudinal direction. Pin supports, however, allow some freedom for slight rotation of the member but do not allow other movements. A fixed support does not allow any relative rotation between the members or any other movements. Remember, the reactions are normal to the support, which may not be always vertical or horizontal. More you restrain, more strong the members have to be because there would be more reactions. Hence, fixed support are the most expensive ones as it has to support all three reactions, two force reactions and one moment reaction. Let's see an example. If we Put one support as a roller and one as a pin for a bridge. During the thermal expansion, daytime and contraction nighttime, the bridge can expand or contract without imposing any stress on its members. However, if you do not put the roller support at one end but put the pin supports at both ends, then there will be no room for longitudinal expansion or contraction, which means the member has to resist such process. This may lead to deformation of the member. To avoid the member deformation, larger members and stronger supports are required. This will increase the cost of the structure.